Now, you'd think a fire would go out when temperatures drop to 32 degrees Fahrenheit. But not in the Arctic. Over there, summer fires can survive all winter, hidden deep underground. But these flames eventually come up again and become a problem for all of us. They release more carbon into the air, bringing hotter days and more fires and floods. So the real threat is not visible. It's only waiting, lurking underground. These zombie fires are becoming more frequent in the Arctic. Now I know we usually link the region with glaciers and snow, but it can also catch fire. The Arctic has boreal forests with trees like spruce, fir, and pine. These trees get buried deep in snow during winter, but when spring comes, the ground is exposed and the plants dry out. So if lightning strikes the region, for example, it can easily start a fire. When temperatures drop again, the fire seems to go out, but it only looks that way. In reality, it becomes what scientists call a holdover fire. It can survive freezing winter for months under layers of dirt and snow. And it manages to do that because of peat. No, not this peat. This peat. Peat is a layer of soil made of plant material that has been decomposing for tens to thousands of years. With enough oxygen, fires can burn slowly and spread underground by feeding on peat. And you won't see a single flame above the ground. Then, when spring arrives and the snow melts, the fire can come back up. Sometimes it reignites in the exact same spot where it burned the year before. That's when the real problem begins. Boreal forests store a huge amount of carbon. When they burn, the carbon in the trees and peat is released into the air and cannot return to the soil for hundreds of years. That makes the planet warmer. It's a dangerous cycle. Warmer conditions can lead to more severe fire seasons and more zombie fires. Those fires release even more harmful emissions into the air, which makes things even warmer. This also makes fire seasons much harder to predict. In Canada, for example, authorities say spring is getting warmer and drier and the snow is melting earlier. That means the risk can start growing before the usual fire season even begins. So what happens in the Arctic will affect the rest of the world. That's why scientists are developing new tools to better understand this event. New satellites and artificial intelligence are helping them track what starts these fires, how much fuel is on the ground, and how easily it can burn. The more they learn, the better we can prepare for the next threat underground.
Let's begin with Naga Fireball. Nope, it's not some spicy Thai dish. It's actually a weird ball of fire that appears out of nowhere in the sky above the Mekong River in Thailand. Glowing balls are alleged to rise from the water to the air. The magnitudes of these balls range from a small sparkle to the size of a basketball. Locals reported having seen between tens and thousands of fireballs per night. This mysterious phenomenon has baffled and amazed people for centuries. Legend has it that the Naga fireball is produced by a giant serpent-like creature called the Naga, who lives in the Mekong River and spits out balls of fire to ward off evil spirits. But science has another boring explanation. The common belief among scientists is that these balls are related to methane gas igniting in the air. No matter what the reason is, thousands of people visit the banks of the Mekong River around October to witness this spectacle. So, if you're ever in Thailand in October and you see a glowing ball of fire in the sky, don't panic. It's just the Naga fireball doing its thing. The fire rainbow. Have you ever looked up at the sky and seen a rainbow on fire? Here I want to clear up a common misconception. The fire rainbow has nothing to do with actual fire. It's a type of cloud formation called a circumhorizontal arc. Try saying that 3 times fast. It's a rare and beautiful sight that happens only when the conditions are perfect. So, how does a fire rainbow form? It all starts with some high-altitude cirrus clouds, which are made up of tiny ice crystals. When the sun shines through these clouds at the right angle, it refracts through the ice crystals and creates a stunning display of colors. The result is a rainbow-like arc that seems to be on fire. Now, you may be wondering why it's called a fire rainbow if there's no actual fire involved. It's because of the colors. This phenomenon has vibrant hues that resemble flames, with shades of red, orange, and yellow. The next natural phenomenon is St. Elmo's fire. It forms when a strong electrical field is created in the atmosphere. Natural events such as thunderstorms and volcanic eruptions provide perfect conditions for St. Elmo's fire to occur. It can also be seen around airplanes when they're moving through stormy skies. On the one hand, I would love to be on that flight and see this glowing thing firsthand. But on the other hand, I'd probably freak out being that close to it. The name St. Elmo is a reference to St. Erasmus of Formia. He was perceived as the patron saint of sailors. In medieval times, some sailors believed that this fire was a sign of divine protection. Seeing this natural phenomenon during a storm meant that they would make it through safely. At the same time, some other sailors perceived this event as an omen of bad luck and upcoming stormy weather. This blue or violet glow has captured the interest of not just sailors, but also scientists. Apparently, the electrical field ionizes air molecules, causing them to emit a bright, glowing light. Next up, we have a special effect from a movie. Okay, maybe not, but the spirit is definitely the same. Let me introduce you to blue jets and elves. See, even the name of the phenomenon resembles a movie title. Anyway, blue jets are blue, cone-shaped bursts of lightning that shoot upward from the tops of thunderstorms. They can reach up to 31 miles into the atmosphere. Elves, on the other hand, are glowing light rings that appear above thunderstorms and can be up to 300 miles in diameter. While these phenomena are difficult to observe, scientists are working hard to figure them out. The way electrical charges build up in the atmosphere during thunderstorms is the key factor for these things to occur. When enough charge builds up, it can create an electrical breakdown that produces a blue jet, or elf. I'll continue with striped icebergs, not the ones you put in your salad. These ones float in some parts of Antarctica. You see, when icebergs break off from glaciers, they can sometimes contain layers of ice with different densities and impurities. This ice mass floats in the ocean and gets gradually eroded by wind and water. The layers of ice become exposed, so with time, different colors and patterns become visible. The stripes on these icebergs can come in different colors, like blue, green, and even black. The colors are caused by various types of sediment and organic matter that were trapped in the ice as it formed. Some icebergs can also have more intricate patterns, for example, swirls and spirals. They certainly look like art pieces. The next mesmerizing thing is again related to ice. Have you ever heard of frost flowers? It has various names, such as ice blossoms and crystallifolia. During fall or early winter, long-stemmed plants extrude thin layers of ice, which can take flower-like shapes. These ice formations have delicate, feathery tendrils. In 2009, a biology team from the University of Washington discovered a field of frost flowers near the North Pole. The team melted a few flowers. They got shocking results. These ice blossoms held an unusually large amount of bacteria. It's like the frost flowers are little gardens, but instead of leaves, they have bacteria. I wonder if they have a gardener too. Okay, but how do these icy things form? Frost flowers are seen when the air is extremely cold and dry, and moisture is pulled out of little bumps in the ice. The air gets humid for a while, and then the cold makes the water vapor heavy. The air wants to release that excess weight, so, crystal by crystal, the air turns back into ice. There you go. This is how delicate feathery ice tendrils are created. It's like the ice is doing its own version of a magic trick. There are more ice formations than we could anticipate. I want to mention another one, because look at these colors. What you see on the screen is called jewel ice, and it can be only seen in Japan's Tokachi River. The river is also known for its crystal clear water. When the temperatures drop and the river freezes, ice chunks move with the waves. These ice chunks look like giant diamonds. Jewel ice is transparent, so it reflects the light differently throughout the day. If you visit the lake at sunset, golden yellow ice stones will welcome you. But if you go there in the middle of the day, they'll appear blue. The color of the reflection is related to how light scatters in the sky. If you love the wonders of nature and taking pictures of these beauties, Tokachi River is probably a place to add to your must-see list. So, have you ever seen one of these phenomena firsthand? If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the US, and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the US population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern US and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern US. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the US prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle. At first, researchers thought their cameras were glitching. It was the only possible thing that could explain the weird view in front of them. Scalding water was blasting upward while cool methane was fizzing out right beside it. Such a combo wasn't supposed to even exist, but it did. Scientists were exploring the ocean floor near Papua New Guinea when they stumbled across a weird deep-sea hotspot. It wasn't like any other hotspot. There, super hot and cool methane-packed gas were bubbling out almost side by side. This almost never happens in nature, so the researchers were pretty shocked. They were cruising around with a deep-diving robot, the Rove Keel 6000, poking around underwater volcanoes in a remote island chain. These volcanoes hide all sorts of strange features, but nobody expected to find a full-on hydrothermal vent just tucked down there. Plus, other research trips had passed through the area before and missed it completely. This time, the robot's cameras lit up the seafloor and revealed a bizarre view: boiling vents and cold gas seeping out of the seabed. They were practically touching each other. As you understand, normally these two things show up in totally different places. Hot hydrothermal vents form when underground water gets cooked by magma and shoots upward, carrying minerals with it. Methane seeps, on the other hand, come from cold, mushy layers of sediment packed with old organic matter. This stuff slowly breaks down and leaks out as gas. But at this spot, the geology created a perfect mashup. Under the volcano sits a thick layer of organic-rich sediment. Magma creeping up from below heats these sediments, but at the same time, it also heats mineral-rich water deeper down. So you get two very different fluids, blazing hot vent water and cooler methane gas. Still, both are traveling upward through the same cracks in the seafloor. When they reach the surface, they escape just inches apart. So you end up with this bizarre little neighborhood where boiling mineral water and chilly methane bubbles are hanging out like best buddies. To ocean scientists, this is like discovering a unicorn that can also fly. It's weird, rare, and super exciting. An even more exciting thing is that right next to those weird hot and cold vents, an entire mini world of creatures has taken over the rocks. The place is packed with huge clusters of deep-sea mussels, long tube worms, little shrimp and amphipods crawling everywhere, and even bright purple sea cucumbers sitting out in the open. The animals are so crowded together that it's hard to even see the rock underneath. Scientists are pretty sure some of these creatures are totally new to science, but they need a special trip just to identify everything living there. The strange mix of hot fluids and methane-heavy gas also changes the rocks themselves. The methane down there is super concentrated, while hot water coming from deeper inside the volcano brings chemicals with it. Together, they create unusual reactions underground. Because of this, metals like gold and silver have built up in the rocks, along with elements like arsenic, antimony, and mercury. It's like a chemical time capsule. The rocks show signs of an older, super hot phase when precious metals were forming. Today, the vents are cooler, but still active. Now, even though this deep sea area is rare and full of life, it isn't safe. Mining already happens nearby, and waste from the huge gold mine on Lahir gets dumped into the ocean. On top of that, companies have licenses to explore the seafloor for minerals and gas. All of this puts the fragile vent community in danger because many of the animals here can only survive in these exact conditions. So scientists are urging for more research and strong protection plans before this one-of-a-kind ecosystem is damaged beyond repair. This underwater treasure needs to be saved before industry wipes it out. This discovery, though, isn't the only unique ecosystem we've ever found. In January 2025, a gigantic iceberg named A84, roughly the size of Chicago, cracked off Antarctica's George VI ice shelf. This ice shelf is enormous on its own, stretching about 280 miles from end to end and about 820 feet thick. During the Antarctic summer, which is November through late February, the top of the ice shelf melts and forms long, skinny pools called ribbon lakes. They got that name because they really do look like giant icy ribbons stretched across the surface. Once A84 broke free and drifted off, it exposed part of the seafloor that had been sealed away under the ice for who knows how long. It was a place absolutely nobody had seen before. A research team aboard the ship Falkor 2 happened to be in the Bellingshausen Sea at the time. As soon as they got word about the iceberg breaking loose, they ditched their original plan. This was basically the deep-sea version of flipping over a huge rock in the woods just to see what's living underneath it. For 8 days, the scientists sent down their underwater robot, Sebastian, and explored depths of more than 4,200 feet. Down in that freezing darkness, they discovered a hidden ecosystem packed with life. Huge corals and sponges formed underwater neighborhoods that were absolutely crawling with creatures. They were not just barely alive, they were thriving. So yeah, the scientists expected to find something down there, but they definitely didn't hope to spot a full-on underwater city of ancient life. There were sea anemones that looked like tiny fluffy trees, sea spiders marching around like creatures from other planets, ice fish, octopuses, and a whole mix of other animals. The entire expedition was live-streamed to researchers around the world. By the way, the recordings are still publicly available if you're interested. Even cooler, the researchers think some of the creatures they saw might actually be brand new species. That's right, genuinely new species in Antarctica in 2025. A few might live only in this one area, and that makes sense because Antarctica is basically its own isolated planet. It's surrounded by the Antarctic circumpolar current, which acts like a giant watery moat that has kept the continent cut off from the rest of the world for millions of years. But even if the new species ended up being known ones, the scientists still found some extremely rare animals, like tiny snails, bristly worms, aka polychaetes, little crustaceans, and even the mysterious phantom jellyfish, which already looks like something from outer space. The scientific name for the phantom jelly is Stygiomedusa gigantea, but no one really needs that mouthful, so giant phantom jelly is fine. This thing is massive. Its bell, the umbrella-shaped top, can be more than 3 feet wide. It also has 4 long ribbon-like arms that can stretch up to 33 feet. That's the length of a school bus. Actually, the first one was collected in 1899, but scientists didn't even realize it was a completely new kind of jellyfish until 60 years later. Its body is mostly see-through with a ghostly purple tint, and instead of normal tentacles, it uses those big flowing arms to grab prey and feed itself. Even though jellyfish don't have brains, the way this giant phantom jelly moved caught scientists off guard. It seemed to steer its long arms with surprising control, especially when it drifted through tight spaces near the seafloor. It looked cautious and almost intentional, which is kinda unsettling. Another maybe kinda sorta smart creature lurking in the dark ocean? Great. The researchers also found bristleworms. Officially, they're called polychaetes, but bristleworms sounds way more fun. These worms are common in cold, deep oceans and come in tons of shapes and sizes. Their bodies are made of segments lined with tiny bristles that help them crawl, sense the environment, and defend themselves. One standout is the Antarctic scale worm, which has shiny golden bristles that make it look surprisingly fancy for a creature living in freezing darkness. So, as you see, there are still tons of places and things on Earth that don't seem real or aren't even supposed to exist. And even with our level of technology, we're unlikely to figure out all the wonders the world has to offer in the near future.
So in Westbrook, Maine, people saw an enormous ice disk in January 2019. This disk was like a wintry carousel. It was spinning away in the Penobscot River. Residents called it everything from an icy lazy Susan to a frozen spinning wheel. It was estimated to be around 300 feet wide, which made it one of the biggest ice disks ever seen. Weirdly, the spinning ice disk notion isn't new. They've shown up in places like Russia and Washington before. They were almost always a perfect circle. So why do they happen? Well, some scientists in 1997 thought it was because river water created a whirlpool effect around a chunk of ice, smoothing it out to be perfectly circular. Yet, in 2016, other scientists claimed that river currents helped these disks get started, but temperature changes kept them twirling. Warmer water makes the ice melt and sink, creating a vortex that keeps the disk spinning. The warmer the water, the faster it spins. Ever heard of the Hessdalen lights of Norway? They aren't the same as northern lights. Think of these lights as glowing balls. They have been seen since at least the 1930s. These luminous wonders show up in all sorts of colors and shapes. Sometimes they flicker, and other times they just chill in the air. The Hessdalen lights can show up 10 to 20 times a week. They appear both during the day and at night. They can last for just a few seconds or hover for over an hour. Interestingly, nobody has a clue about what exactly they are. The efforts to understand these lights include Project Hessdalen, started in 1983, and later projects like the Triangle Project. Despite ongoing research, there's no consensus on the origin of the lights. Some suggested explanations include misperception of celestial bodies, aircraft, or mirages. One theory ties the lights to airborne dust from mining, while another mentions plasma formed by ionized air and dust during radon decay. Okay. Ringing rocks is a cool geological thing you probably didn't know about, and it's our next stop on the Mysterious Natural Phenomena Tour. You can find them in Bucks County in the U.S. If you give these rocks a hit with a hammer or another rock, they start ringing. Scientists have been studying them, but the mystery remains. There are different hypotheses about this one too. Things like the size and shape of the boulders and how they're stacked can affect the sounds they make. But that alone doesn't give them the ability to ring. Even though the sound is often described as metallic, it's likely because of the rock's density and internal stress, not just its iron content. A scientific experiment from the 1960s suggested that the ringing ability came from some internal stress, not external weathering. The live rocks found in the middle of boulder fields showed expansion or relaxation after being cut, indicating internal elastic stresses. A slow weathering rate in dry fields could cause these stresses. The relic stress theory suggests that these boulders act like guitar strings. A de-stressed boulder gives a dull thud, but a stressed one resonates at different frequencies. The boulders can still ring when removed from their fields, leading to myths about stealing them. Most fields are now cleared of smaller ringers, and breaking large boulders stops the ringing. Large equipment is needed to move the remaining small ringers, weighing over a ton. Now let's talk about the Naga fireballs. They only show up along the Mekong River in Asia. These picky fireballs hang out in just a 155-mile stretch of the river. The reddish glowing balls rise naturally from the water into the air. Their scope ranges from small particles to the size of a basketball. The reported number of fireballs varies, from tens to thousands per night. They can be spotted all year round, but they seem to go wild during the full moon in late autumn. Why? Well, that's just another one of their little mysteries. Some have tried to explain the phenomenon scientifically. One theory suggests that flammable phosphine gas from the marshy environment could be the cause. However, skeptics argue that spontaneous ignition isn't likely to be the reason. Another scientific explanation involves free-floating plasma orbs created when surface electricity is discharged into a solution. Still, these typically occur in controlled settings during experiments, and not naturally. We can carry on with ball lightning. It's a super rare thing, a glowing ball that shows up in the air. It likes to make an appearance close to the ground during thunderstorms, hanging out with regular lightning. It can be red, orange, yellow, white, or blue, and it's often accompanied by a hissing sound and a funky smell. This flashy sphere of light is a quick show. It lasts just a few seconds, zooming around, and then poof, it's gone, sometimes quietly, sometimes with a little pop. Ball lightning might seem like a troublemaker, but it's usually harmless. Sure, it's been known to burn or melt stuff on occasion, but it's not out to get us. Scientists aren't entirely sure why it happens or how it's related to regular lightning. People have been tossing around ideas like weird air or gas behavior, high-density plasma stuff, or even a vortex of glowing gases. Even microwave radiation trapped in a plasma bubble is on the list. But don't get it confused with bead lightning. That's a different one, more like a string of beads. And it happens when a bolt of lightning sticks around for a good chunk of a second. Shh! We're now at the Mapini Silent Zone. It's this spot near this place in Mexico. The story goes that in this desert patch, you can't pick up any radio signals or talk to anyone. In July 1970, a rocket from Utah went off course and landed here. It was carrying some sort of cobalt. Authorities had to haul away tons of soil from the crash site. Now, thanks to the cleanup, the Silent Zone is wrapped up in myths. People talk about weird magnetic stuff, messing with radios, and about plants and critters going through mutations. Well, locals go with it, boosting tourism in the region. Alright, we can now talk a bit about the sun. Well, it's not just a big ball of fire. It's got an outer layer called the corona. Think of it as an invisible sun jacket made of gases. You usually can't see it because the sun is super bright. But there's a trick. During a total solar eclipse, when the moon slides between us and the sun, the corona shows up, all glowing and white. The corona is scorching hot, even hotter than the sun's surface, which is kinda weird. Scientists are on a mission to crack this heat mystery. They found something called heat bombs shooting from the sun into the corona, exploding and warming things up even more. But that might be just one piece of the puzzle. You see, the sun's surface is like a playground covered in magnetic fields. These magnetic fields create cool shapes on the sun, like loops and streamers. Special telescopes help us see these cool patterns up close. The corona stretches way out into space, and from there, it sends out the solar wind that moves through our solar system. Its particles are so speedy that they escape the sun's gravity. So, there's this cool spot called Kuala Sangalore Beach that you can only check out when the tide is low. The timing changes every day, and you can't get there when the tide is high. Most of the time, it's hiding under the sea, not even on the map. But when the tide's just right, bam, it pops up. Kind of like Malaysia's own version of Salar de Uyuni. People call it the mirror of the sky, because when it's not underwater, it turns into a giant reflection of the sky. An awesome spot for cool Instapics. Besides being a sweet travel spot, it's also home to a bunch of marine life, like sea and baby clams that live all over the sandy shores.